So feel free to interject just like we are in a normal class, in a regular class, anytime. Feel free to ask as we go on. I know the time I'm using the free version of Zoom, so it may go off, but I'll repost another connection, one last one. I'm supposed to do like 3 of them each pack. We shall be doing 3 Zoom sessions for each class. So I'm going to do a third one so that we can be able to finish up. Because I'm using the free version. I only have 40 minutes for each session. So in case we go off, I'll reschedule another one, then you can log in again. Is that okay?
Okay.
All right.
Okay.
Okay. So the deadly sins are basically software security. Deadly sins are basically defects in software when you're designing software. Your problem could be in the core of your programming, the way you have designed your program, the way you have written your program. Okay, so the first sin usually is going to basically be an effect of probably a buffer overflow. Maybe you have you didn't check your code very well. This coding issue is usually in C and C++. Usually in Java, you don't have this kind of things. Java, Python, usually I don't have that, but in C, it's very prevalent there. So you probably haven't experienced this kind of crash in your programming because it's usually in C. I did C and C++, but it was really hard to code in those languages. You had to really be careful about the code. Otherwise, you would get and you'd easily get an overrun, a buffer overrun. So this first sin is called a buffer overrun. Sometimes it's called smashing the stack. Okay, so usually it occurs in programming in C and C++ programming languages, but it's not so popular in the modern day high-level programming languages like Java and Python and others. I don't know what you guys are using, but you probably haven't experienced this one. I know not many of you are doing C and C++. Anyone doing C and C++?
Not yet.
No.
Yeah, but you have to try to do them. You have to try out, at least see what it's all about. Yeah. I did C and C++. They are not very easy languages to use.
We kind of did them in robotics.
Yeah, they are popular in robotics. But try them. I have a class. I have a class that I can connect you in case you want to do. You can, if you want to self-teach yourself, self-learning. If you're ready to self-learn, I can put you in a C and a C++ class. If you're interested, please let me know. You can inbox me on that.
Okay.
Yeah, but this is what the buffer overrun looks like. Since you guys have not done C, I don't know that you can interpret this. So you can see there the buff, it's set to 16. It can easily overrun your program if someone encodes that in your software. It can easily create a vulnerability within your software if they do that. I don't know whether we can be able to buff in Java. Maybe we can try that out in Java and see what it looks like. We can try it out, check out that if this can work in Java.
Yes.
Yeah, so you check it out and see. But it's mostly in C and C++. And don't forget, if you want a C class, you'll let me know. I can fix you in one to self-teach yourself. So these are the components you're going to look for when you're looking at a buffer overrun. If you want to spot the sin, you look for the inputs within the command line. So you're going to look for something like this. The hacker will do something like that. Okay, you're going to look for this. Okay, in your program, in your source code, you look for that. So that is, you look for that input. And I don't know why Freddy. I'm trying to admit Freddy, but he's not coming in. So you're going to also transfer data from that side input to an internal structure, and you're going to handle some of those calls by calculating recalculating the buffer size. Okay, you need to recalculate the buffer size and allocate it to a different number instead of that 16. Okay, so this number here, you may have to reduce it. Okay, you may have to reduce that number from 16. If you find that issue in your coding, you have to edit that particular buff overflow. So that's the first thing that you're going to look for. You're going to spot it in that way. And then the redemption steps, you're going to replace that dangerous string, obviously, change it to no other string. You're going to audit your allocations, check any loops and arrays. But like I said, you have to be really good in C to do all this. Maybe you can try it in Java and see whether it works, but it's for C and C++. Okay, so you have to replace any of those the loopholes that you have found out in the system, in your source code. Okay, so you have to replace this in your source code. Then we have another scene. Did I skip something? I think I've skipped another scene. Scene number 2. Okay. So we've seen scene number 1 is a buffer overrun that the hacker will place in there. So the redemption step is to replace that string. Okay. Check your string and replace it. Also, you may be dealing with an SQL injection, something to do with your scripting issue, cross-scripting issue in your SQL or SQL database. The hacker can put there a SQL injection in your code. So you may have to look for that as well, because that can mislead anyone and you think you're okay. There is also the integer overflow. Scene number 3 is the integer overflow. All these overflows occur in, all these issues are mostly, as you can see, they are occurring in C and C++. And also Visual Basic. Visual Basic is an old, is also an old programming language that also suffers from such sins. All these issues have been solved in the current high-level programming languages. So in scene 3, you're going to look at an integer overflow. Okay, maybe you may have to check your source code and look at the at where you point out the problem. Look for where the problem is existing. You can just rewrite down the code and look for that issue line by line. Okay, so here this is usually to do with integers, with your int, where you have declared your int. Then you also have another scene number 7. Scene number 7 is to do with weak passwords. Okay. The other thing you're going to look out for is a weak password. Usually for passwords, make sure you're not writing your child's name, you're not writing your birthday, you're not writing your name. I think by now everyone knows how to write a good password. uppercase letters, lowercase letters, special characters, like a space, like a hash, okay, that kind of thing. Okay. So scene number 9 is weak passwords, and then scene number 10 is information leakage. Okay, if your information leaks out, definitely you're going to be compromised. Okay, this is usually an issue with the design team. Okay, your design team can decide to leak information, probably accidentally leak the code to people who are not who are not cleared to access this information, and then they can easily sell you out. So you need to make sure you watch out for information leakage. Otherwise, your program code, if it leaks to the wrong person, that can be another defect in your system. And also trusting the network name resolution. Don't trust DNS, domain name system, too much. Domain name system is one of the weakest links on our networks. Try not to trust the DNS and also the Windows Internet Name Service. Okay, the DNS resolves names like facebook.com to an IP address. So during that resolving, hackers usually are able to access your information. Then scene number 12 is about an authenticated key exchange, which usually doesn't happen nowadays because now we have keys like secure socket layer and transport layer security, which have very good encryption, especially when you're using HTTPS. When you're browsing, make sure that you're using HTTPS. Like you can see at the top in my URL there, make sure that you're using that. If you're just using HTTP, then definitely you're going to encounter this scene. Okay, so if you're using protocols like transport layer security, you're using secure socket layer SSL, those can be very good at authentication to make sure that you're communicating with the right person. Authentication means that you're communicating with the right person on the other side, the correct person, not just a hacker along the way. So that is scene number 12, an authenticated exchange. Scene number 13 is cryptographically strong random numbers. Okay, so the biggest sin that we commit is sometimes we think that we have encrypted the information that we are working with, but if it's like too many random numbers, sometimes it doesn't work. So a true random number can be generated using entropy generators, okay, or cryptographic pseudo-random number generators. They're generators that generate crypto keys. So sometimes when the crypto key number is too big, it's probably a hacker trying to hack you. So you think that your data is encrypted, and yet it's not. That is scene number 12. Then scene number 14 is poor usability. Usually users are the weakest link in security. So even if you design your software very well, it's very well encrypted, you've checked for all the errors, buffer overflows, overruns, you've done everything, but the user uses the software wrongly, and then that's going to be another sin. So you need to educate your users to make sure that they are using the software correctly for whatever purposes they are doing. Okay, so I don't know whether we are getting each other there. We also have the redemption steps on that. Make sure your user interface has, you've designed it very well to ensure that the user is using it very, because sometimes it comes from the designer, from the software engineer themselves. If you've not designed a good user interface, then the user is not going to do well as well. They will have issues with your software. Like what? What issues can come in there? Maybe you have not told them how to set a good password. Okay, you've just put their regular characters. You have to force the user, for example, to encrypt their passwords. Okay, that is one of the design issues that we may have. And don't relax the security policy. Make sure that your security policy is tight. Policies include things like making sure that the user changes their password maybe every month, every year, something like that. So I'm about to go off.
Exactly.
Yes, my time is expiring. So I'm going to open the next session to questions. Or we can discuss some of the issues we have discussed up there in the slides. So additions, subtractions can come in the next session.